One, two, three, test. Okay, I think the sound is working. Okay, right. I think I might be having some problem with my microphone, so I'm not sure whether it will disconnect while I'm talking. Hope not. Right, so today I'm starting a new series of live streams, which are basically things I normally like to do anyway. I like to go through papers in deep learning, and I like to look at the papers, understand the details, and also, if possible, try out the source code. Unfortunately, not all the papers will have source code, but the ones that do, it's always worth looking at them. And what I'll try to do, I'll try to time box it to 1 hour, no more than that. And the idea is, if within 1 hour I'm able to, well, have a basic understanding of the paper, and also be able to try the source code, whether then I'll decide later, right, at the end of this live stream, I'll decide if I will do another session on this paper or not. If I find the source code is impossible to run, and that happens, a lot of the times you'll find a GitHub project with source code that doesn't run. It's only there because they've decided to publish it. But actually, I know this paper, PIFu, is definitely worth looking at. Okay, this paper, PIFu, is a paper that Google Forum is actually using as a reference. And I've already released the video on this paper from Google, which didn't have source code, unfortunately, so I couldn't try it. Okay. And you basically need to understand this paper in order to understand this paper, right? And it's actually a groundbreaking paper in the area of 3D deep learning. Okay, for several reasons. First of all, I wanted to mention that this paper doesn't apply only to people, right? It's not just about human reconstruction from 2D to 3D. It can also apply to any object in theory, okay? And one of the most important concept that this paper introduced is the concept of pixel-aligned implicit functions, which are functions that can be used to define a surface in 3D, okay? And this is basically the most important part of the paper. Is the fact that it's all about implicit functions, okay? So we have here, I'm just going to highlight some, okay, this is the architecture diagram of the paper, which if you've had a look at a forum, right, it might look very familiar, okay? So this paper here was, okay, so the forum paper was heavily based on this. And I'll just go through the architecture very quickly, and then I'll try the demo, which you can also run in Google Cloud. Okay, so the idea is you give it an image, okay, and in the case of PIFu, you also need a mask of that image, okay. Then this image is given to an image encoder, okay. There's two image encoders, one for the 3D geometry and the other one for the texture, okay. The idea is they use this an implicit function, which is basically, it's like a neural network actually. So this implicit function is, how do I say, there is a neural network basically that is the implicit function at the end of the day, okay? So this implicit function will, So first we map these. So if I remember correctly, we go through each point. Yeah, we take this cube here. Yeah. For each point in this cube, we map this point from the 3D space to the 2D space, right? And then using the feature maps of the image that we want to reconstruct, right? So the feature maps are calculated by applying the image encoder to the image here, right? And the feature map is basically, you can think of it as filters, right? That are applied to the image, which will give another small image, which basically, if you look at it, it looks like something out of, it doesn't make any sense to a human, but the neural network understands it somehow, right? And so each filter basically will allow the neural network to understand. It's looking for features, right? And that's why it's called feature map, right? So for example, maybe it's looking for straight lines in the image, right? And then it'll apply a filter that will allow it to discover the straight lines in the image. And then for each pixel, you will have n feature pixels, okay? So we go through each point in this cube, we map the point to the 2D plane, okay? And then we go and pick up, basically we retrieve for that point the features which are basically assigned for that pixel, right? So each pixel will have a number of features that have been calculated. So it's a really complicated algorithm, right? But basically at the end, you have this cube, right? Which has a bunch of, basically with points, which have associated to it features, right? And let me just go through. This is done for geometry, and then it's also done for texture, okay? And the idea is, once we have this feature, let's call it a feature cube, right? We then apply the implicit function, which is the neural network, and then for each point, it basically says whether this point is in or out of the surface, okay? Right? So it basically says, okay, so this point is outside the surface or inside. Okay, there's nothing else. Okay, there's no distance, there's nothing there, right? And then at the end, right, with all this information, we can actually use the Martian cubes algorithm to reconstruct the 3D model of that person, okay? So the same can be done for the texture, okay? So it's a similar algorithm, but instead of dealing with geometry, we're dealing with colors. Right. Okay, so this is basically the very quick overview of how this works. And I'm just going to go and open Google Colab and show you. This is actually, okay, this is the GitHub, okay? You have some sample images. I don't know, maybe this is the author, I don't know. And then there is a mask. I've created one for myself as well. So I'm going to try first the demo with these images, with the default images, and then I'll try my own. And I honestly don't know what's going to be the result because I haven't tried it yet. So it might go very wrong or it might go well. So I'm going to try the inferencing part. I don't think I have time for the training. The training I'll try to do on another live stream if there's any interest. Okay, so let's take a look at the link. There's a link somewhere here for Google Colab. Demo with Google Colab. Where is it, the link? Okay, here. So you can try this yourself as well. It's very simple demo to run, actually. And if then we go back to the paper, I think I just want to go in more detail about certain things that, I mean, this paper is really important if you are interested in 3D deep learning. There's many papers which are based on this paper now. Even the Google's paper is based on this one. So basically, it's just downloading a trained model that they already have. So this model was trained on commercial 3D models from a website, okay? And they couldn't make them available because they had to pay for them. There's a license for it, but there is like they've managed to, they provide an example on how you can train this model using a free 3D model of someone. And if you are able to get more data, then you actually could also train the model yourself. Okay. So visualize reconstruction. Okay, so this is a very simple demo. It's going to create an image and a 3D model of someone. Actually, a 3D model, video. Takes a bit of time because it has to install PyTorch 3D here. So this could actually take a few minutes. While it's doing that, maybe let's go back to the paper. Just have a little bit more. So, because this is a really, so Martian cube algorithm, it's really important. And this is an algorithm from computer graphics. It's nothing new. And it's actually quite interesting algorithm to try. Maybe one day I'll try to do live coding and try to implement this algorithm, but it's not very simple. Basically, right? Once we have the implicit function, which defines the surface, and the implicit function will basically say, okay, this point is in or this point is out. Using that function, we basically just, we mark all the points that are in or out, right? And then with the Martian cube algorithm, we use a table of triangulation rules, and then we connect the vertices, basically, right? And then there's a rule. There's like a table where you have to, you need to know which vertices you can connect, and you follow this table. And then at the end, you get like this mesh, right? This is actually a mesh. So the implicit function is actually very efficient in terms of memory space, because it's, but then it's actually why the paper says it's actually very efficient, because memory wise it saves a lot of memory. And that's probably why it makes it easier to train, to do machine learning on it, because it doesn't take as much memory as normal representations of 3D models. For example, it's talking about voxel representation, which is, voxel is basically, I could just show an example. voxel representation. It actually looks like Minecraft. A voxel. Let me see if I can find a voxel. You see, it's with cubes, small cubes, right? So you define. Yeah, this is a voxel. It's like a Minecraft. Minecraft, everything is a voxel, really. Okay, so we have the so they use the deep fashion data set. So the actually one thing that PIFu can do, right? It can do a single image to a 3D model, but if you have more than one image, it then can also combine the views it gets from the different images of the same. Let's say you do like a 360 rotation and you take several pictures of the person you want to reconstruct in 3D. With PIFu, you also this method allows you to do a multi-view reconstruction. Okay. If you compare this with the Google paper, which I talked about in another video, it doesn't separate the color, like the albedo. So the lighting is actually embedded in the color, so you can't separate it. And that's probably the biggest difference to this model here. Wow. And there's another difference is that in this paper, they have two neural networks, one for the texture and one for the geometry. In the Google paper, they managed to they have one neural network that can basically tell you the geometry and the texture at the same time. And the great thing about PIFu is that, okay, here you're talking about human people, right? But this algorithm or this methodology can also be used with any type of object, because any type of object can be, in theory, represented as a implicit function, right? For the training, let me just see if it's still running. Still running. Okay. The training. Right. You can still hear me, right? Okay, cool. Um, oh, that something which is really important to mention about PIFu is that it can, in this case, right, you have this person is facing forward, right? But PIFu can also basically reconstruct the surface that is behind, that's occluded. And the reason why they can do that is because during training they use images. They also have like let me just find the training data in the appendix. You can find it, so the examples on how they trained it. Let's see which one is it. So you put hours. Well, when they train PIFu, they have the full 3D model with the texture, front and back, so they can actually, the neural network will just basically guess how the back looks like. It's not very difficult, to be honest. Of course, this only works for objects like, well, you need to train the model in the type of object you want to reconstruct, right? Otherwise, you will not get the what's in the back right. Let's see, is it finished? No, not yet. Takes a really long time to install PyTorch on Google Cloud. So the reason why it's called Pixel-Aligned, right? It's actually because of the way we calculate the feature. I mentioned that we calculate the feature maps, right? From the single image, right? And the feature maps are like, I don't know how many in this case, but it can be a big number. It could be like something like 256 feature maps for a single image, right? So you can think of 256 feature images stacked on top of, basically you can stack on top of each other, right? So you have 256 images stacked, right? So the reason why we call it pixel line is because we are taking the points, for example, from, in this case, we're taking it from a, like, it's not Q, it's, let's call it a surf, a 3D, what do you call it? It's a 3D space, yeah, they call it a 3D space. So you take a point from a 3D space, you map it 2D, and then you take all the pixels from the feature map and they are aligned to the point, right? So we are doing pixel alignment. That's why it's called pixel aligned. Right, so we have still running. So the difference also in terms of, in the case of this paper, we are using implicit function, which is in or out, right? It's a very binary thing. In the forum paper, they are using distances. So instead of just saying in or out, they will calculate the distance of each point in the in the space, in the 3D space, to the nearest surface. Yeah. So that's another big difference. Yeah, sorry, I'm a bit silent. I'm just waiting for this to complete and at the same time just reviewing the paper again. I've read it before, but mainly it was only because I was looking at this paper. So the limitation of PIFu and not so much about the method, it's more how they train it. They use 3D supervision, right? And they need to have 3D models, right, for the training. And it's actually quite expensive to get 3D models, right? So you only can have like as you can't really have hundreds of thousands. You can only have like hundreds at most, right? And the problem with that is that your data will be very limited in range, and then you'll have a lot of bias in your data, and it's also very expensive. So they could, well, in this paper they probably didn't think about that, but in the Google paper they said they're going to use differential rendering, and differential rendering is a technique that allows to train like a neural network for 3D deep learning using 2D data instead of 3D data. And they can train the neural network in that way because they they basically take they can like they use like images of the 3D model or the of the subject, right? Different views, yeah. Okay, I think it's finished, so I can just go back to this. Right. So there's an error for some reason. I don't know why it failed. But it's not. I don't think it has run everything. So we've run the train model. Have we run PIFu? Let's run it again. Oh, there's an error now. Nice. Invalid key. Python. I wasn't expecting to get an error. Serialization function. PyTorch 1.4.0 installed. I need to check how I need to see what the PyTorch version is. Let me see. Version check. Just googling it. Okay, let's do that. So we have a hiccup, likely to do with some, maybe the PyTorch version is not the one we expect. Okay, so this is 1.12. Also, I want to go into the GitHub project, check the issues. This old. How to upgrade the PyTorch version. We have I don't want to use conda, I just want to use pip, something like that. You see. Windows. Okay. So we have installed PyTorch 3D and okay, it needs an account. Okay. 44. Checkpoint. It's trying to load a model. An invalid log key. The test.should to see what's actually doing. Valid log key. I think it's just an issue with the version of PyTorch. Okay, so what do? It's tested on. This is 1.12. Oh, okay. This is actually much. Sorry, I was confused. So this is 1.12. This is too new. So I need to downgrade it. And that's not nice. Downgrade PyTorch collab. Okay. So this used to be PyTorch 1.4. And now it's PyTorch 1.12. 1.4.0. See if it works. So something went wrong. I wasn't expecting because I've tried some time ago this demo and it was working fine. So this is actually already useful for anyone trying this on Google Colab. It doesn't work unless you do something to it to make it work. And I hope this is enough to just downgrade the PyTorch library. And I wonder if it's going to have any problems with QDNN, CUDA version as well. We'll find out. And then do I have to reinstall PyTorch 3D? We'll find out as well afterwards. I hope not, but I have a feeling that it's going to be required. Things go wrong. Okay, so now I have to restart the runtime. And let's see if we are lucky. So I'll just do it again just to make sure. Restart runtime. And let's see the version of PyTorch. Okay, 1.4.0. Fingers crossed. I'm just going to make this a bit, put this up there. We already have. So let's see. Run test. What? Let's do it from the beginning. It probably didn't. I didn't have to download the model again, but never mind. Okay. The next one. Run this. This is still the same version. And then let's run the test. Oh gosh. What's this? Cannot open. Oh. Okay, so we have extension. This is where you get into version hell because now it's complaining about something else. I'm wondering if this is something I can easily solve. Let's see. Oh, it's nice to not have any help there. The closest. So I think I also need to downgrade torch vision. Or is it nothing to do with that? Yeah. I need to go into PyTorch. Torch vision. I need to know what's the correct version. Point zero. This is the one. So CUDA. Okay, torch vision is 0.5.0. Going to do this here. Pip install. Vision. Zero point 0.5.0. So the previous one was 0.13. Okay, so let's see if this helped. I think I was I shouldn't say too early, but it looks like it worked. So I think I'll have to save this notebook somewhere and provide maybe a link to anyone who wants to try this out. And this part should work now. I say it should work. But of course, PyTorch 3D. What's okay? The thing with PyTorch 3D, we're installing it from GitHub, and it doesn't have a version as well. What's going on? Anyway, this is not doing the actual 3D reconstruction. This is just creating a video from the 3D object that was already created in the previous step. So object path is this one. So there should be already a 3D model. I think I might skip this part of the demo because now PyTorch 3D is not working. That's why I always feel tempted in trying. No such file. So I can always check the requirements. What was the PyTorch 3D version they used? Problem with downloading a stable version without specifying what is the version number is that things change quite a lot normally in the APIs, and then so it's not even here. So the actual PIFu doesn't need PyTorch 3D. It's only for the video. So sample images, results. Okay, so the PIFu demo already has an object here, and it already has. I don't know if this was also reconstructed. I don't know if that was that from. Okay, the original image is this one, and there is a mask. And then this is a 3D object, which I can open this in, I'm going to open in Blender, and we can have a look. I don't see the texture. Let's have a look at the texture. The texture is somewhere in the downloads. No. Result. No, this is not what I want to do. So I'm going to import an object. Where is it? Okay. I haven't used Blender for a couple of months, and then I already forgot. I'm in the wrong mode. Modeling. Let's go to modeling. It's easier to find. Okay. Delete. I didn't want to delete the Let's do object mode. Yeah, I'm going to do this from scratch again. Do it first, then import the object. So this is without texture. I think I'm not sure if the texture is included in here. I think there's a separate file normally for that. Text render. Should be another file. Oh, this probably is. I think I know. Okay, I think that's the texture. Missing something, of course. Just mm, create block white. Oh, object texture missing. That's what I was wondering. Oh, I see. Mesh. Why does it have to be mesh lab? Uh, maybe I can see it directly with Windows. Let's find out. This doesn't see the. So it's supposed to have per vertex color, right? Which means I don't know if Blender supports that. Um, you mentioned Mesh Lab. Maybe I will just go with that. Anyway, before I spend any more time on this, I'm going to try my own images, right? So I'm going to delete from here. I'm going to delete the sample images. And I'm going to upload my own. I forgot one thing. I just need to make sure I don't. I want to know what the size of the image is. Just find out. It looks like a square. Downloads. So I have prepared, my own version. So I have here in Photoshop, I created. You just make sure it fits in the screen. See, with my. Oh, this is so. So I have a picture, and I have a mask. I lost the layers for some reason. Oh yeah, here. So huge. So you see, this is my. Anyway, this is my layers. This is my mask, and yeah. So I just need to know the exact size in pixels that I need, so I don't produce something that's huge. It's a very tiny image, 512 pixels square. Okay, that's what I needed to know. So I can go into my Photoshop. I can do, hopefully I can do an export with the exact size. So let's do that. 512, 512. I wanted to do cropping. Um, I don't know if it has to be a square image. Normally, models need to have square images, but because we have a mask, it might not need a square image. So I just need to crop it. So 512, 512. Oh, it's keeping the proportions, right? I know I can crop in Photoshop, but I'm not really Photoshop guru. Okay, doesn't matter. Doesn't matter. I'm just going to export this as is, and hope that the model is able to cope with the slightly different sizes. Okay. If it can't, then that's something they can improve. So let's just do PIFu. I'm going to replace my previous mask, which was huge. And now I'm going to, this is my image. Export it. 512 as well. Okay, export it. To 3D. Going to name it appropriately as well, because I think it has to have the same name as well. So if I go to PIFu folder here, so I'm going to call it codemental mask, and then codemental. Okay, so I'm going to upload this to the Google Colab. What is it? Google Colab. Hello, hi Nare. So let's see what is the. Where is I've lost my tab. Okay, it's here. Right. So I'm going to upload it here now. Where sample images are, and we have codemental and the codemental mask. Right. Have now sample images there. Takes a bit of time because Google Colab is actually very slow on uploads on purpose. Wow, it's still 14 megabytes. Shouldn't be that big. That's huge. Something wrong. Why 14 megabytes? Anyway, let's see how it deals with 14 megabytes images. Hopefully it will work. So the only thing I'm not sure about is if the script is able to deal with the... Okay, I need to change the parameters probably. So I need to go into that folder where the script is and change the names. So I'm going to try and not change anything. Where does it get the... I don't know if it's able to actually just... Oh. Okay, it did pick it up. So it's already took... Okay. All right, so as I guessed, it doesn't like it wants a square exactly as it wants. So I need to crop it. Let's do that. I do that in a oh, sorry, I can crop a square. I don't know how to do that in Photoshop. Okay, I think I know. Let's just eyeball it. But the problem I have is I already have a mask showing. Um, there should be a better way. Image size. Okay, that could be better. So image size. This frame your photo by dragging the corner handles around the path of the image you want to keep. Oh gosh. Tips and tricks. Can be experiment with different cropping methods by trying the techniques below. Not this something I want to do at this time at night. Okay, there is a way to do it. Cropping. Oh, I see. Just want to make it a square. Get a square, man. So it's 452. Yes, this is the. So I need to make it 3024. I didn't want to eyeball it, but that's what I'm doing. So I'm hoping this also. What happened to my? Hang on. I I'm doing it in the wrong place. Huh? Disappear. 2024. Okay. And now what do I do? Do I just press enter and that's it? Oh, cool. And I still have a mask? Wow, this is good. So I'm going to export again. 512. Um, I'm wondering if it has to be 512. In general, it has to be 512. I'm not going to risk it because tensors are very precise. So 512 pixels. Okay. Yes. Now let me do the picture. Export as 512. I can paste this one. Right. So now I should have the exact dimensions. So there is no excuse for this to fail. Right? Let me delete the previous ones. Oh, this one. And now upload a new images. Okay, and that should be quicker actually. Okay, they're already there. So let's run the script now and see how good my 3D model is. And I still need to figure out how to get the texture to show up. But it seems like it was able to produce some results. So let's refresh this. Yay. So I have my own 3D model now. And I have also my own screenshot, I guess. So let's see. This is me. And this is my 3D model. Ooh. But the texture is not showing up. And the reason why is because they are not using normal textures. They're using per vertex color. And one of the advice is to download MeshLab. I hope that's free. And I could just open that in MeshLab, apparently. Windows, download. Download. Yeah, let's go through here. So there is a Windows version. So I'm only downloading MeshLab because I want to see the 3D model without really spending a lot of time in Blender trying to figure out how to view it. I'm sure in Blender you can do it somehow. It's just that I don't think it's worth the time spent doing that now, especially when it's almost midnight. Okay, so now where's MeshLab? MeshLab. Okay, I'm just going to run it and hope it just runs like that. No hassle. And I'm going to open my 3D model. And this is going to be a glorious ending for this stream. It's going to be my 3D model in color. Once I can find it. It seems like a new project. So I need to create a project and then import. Import mesh. Let's do that. So downloads. And that's it. Wow. Okay. I mean, this is it. This is the result, right? It's not perfect, right? I look a little bit. I mean, this is my first experiment. This is a 3D model in a random picture I had from a holiday, right? This is promising, actually. It might look quite bad result, but to me, this is This is quite cool with the texture, right? So the new paper from Google is supposed to be a lot better than this, but we can't try it, right? But this one you can actually run the code and see for yourself. And this is the code, this is the methodology that Google is using in their latest paper. 1 second. Yeah, and I think that's about it. ML ops. Okay, all right. Thank you so much. Right, I see you asking some questions about ML ops. Yes, I want to cover that topic in the future. And yes, Nare, I'm also planning to look at the. You've sent me some GitHub links for some interesting. Well, I think it's very similar to what I did already, right? The satellite image 2D to 3D that should be using pixel intensities, right? But anyway, I haven't looked at the paper. I'll have a look and see what it is. And at some point, if I find, I'll try to do something like this, like a live stream, and just go through it and see what I can do with it. Yeah. And if you like this live stream, don't forget to click the like button, and I'll see you again soon. Happy coding.